Hey everyone, I'm Alex. Welcome to Awful Astronomy's This Week in Space, where we discuss some of the latest developments in and around astronomy. Let's get started. In these two absolutely stunning pictures, you can see NGC 6027 as taken by the James Webb Space Telescope. This is called a planetary nebula. It's the expanding shell of illuminated gas thrown off by a dying star. You can see that the two are nearly identical, but not entirely. The one on the right has these rings, while the one on the left doesn't. Plus, the color is different too. What's going on here? Well, the picture on the left was taken in the near-infrared range of light. The red areas are cooling molecular gas, like molecular hydrogen. The blue area around the center is ionized gas that is still being heated by the core. The picture on the right is a mid-infrared picture. It also shows the same gas in its vibrant blue, but also the rings of dust surrounding the whole scene. More importantly, it shows the original star, that pink glow right in the center. Since you can very clearly see unevenly spaced outflows of gas, astronomers believe that this might have been a system of two or more stars, but that's not confirmed yet. The rings actually also point to a second star being in the mix, since it could have carved out material expelled by the dying star by circling around it, thus creating the sort of bullseye pattern that we see here. The rings, however, might also be evidence of the original star spewing out material in pulses. Eventually, this beautiful display will dissolve into the interstellar medium, where it will contribute to new star and planet formations, enriching them with the heavier elements created through fusion at the star's core. This process is how heavier elements, like the ones that make up our bodies, first came into existence. AI-powered robots are taking over the International Space Station? Well, no, not really. Last Tuesday, Japanese astronaut and station commander Takuya Onishi conducted a test of Simon, a bowling ball-sized robot powered by artificial intelligence. Its job was to control other free-flying robots on board the station. After activation, Simon began piloting a free-flying camera to look for objects hidden in one of the modules. The goal is to free up the crew's time for research and relaxation while delegating more menial tasks to robotic helpers. Meanwhile, other members of the team practiced shock therapy on each other. You see, spending extended periods of time in space can result in serious muscle and bone atrophy, which is why all astronauts aboard the ISS are required to exercise about 2 or 2.5 hours every day. But even that's not enough to negate the effects of living in microgravity for as long as they do. Astronauts usually spend 6 months per mission aboard the ISS, although some have been known to stay for up to a year. For extended missions to the moon and beyond, we really need to figure out how to protect ourselves from muscle and bone atrophy, since those missions would last much longer. So, NASA flight engineers Nicole Ayers and Anne McLean studied the effects of using small electrical impulses with the goal of improving muscle function in their legs. Maybe one day we can replace leg day at the gym with electric shock therapy. Here's hoping. Researchers from several Chinese universities, including Tsinghua University in Beijing, as well as members of Pennsylvania State University, teamed up for this paper titled Dynamical Instability of Multi-Planet Systems and Free-Floating Planets, which I found fascinating. Free-floating planets, also sometimes known as rogue planets, are planets that are not bound to a solar system. They can form in one of two ways. The first way is through gravitational collapse of free-floating gas clouds. When such a cloud has enough mass, the pressure and temperature at the center will cause nuclear fusion to begin, thus creating a brown dwarf or a star. But if the mass of the cloud is lower than approximately 13 Jupiter masses, fusion will not begin and we end up with an FFP. The second option is that the planet is formed normally in what is called a protoplanetary disk around a young star, but is later ejected by the gravity of another object within the system. And that's what this paper is looking into. If you're wondering how we even find FFPs, there are again two options. One is direct imaging, but that requires the planet to give off thermal energy the way sub-brown dwarfs do. It's not suitable for even smaller objects. Option number 2 is microlensing, which relies on the deflection of light through the gravitational field of a planet. So we are observing a planet which deflects the light coming from a source directly behind said planet. This method can theoretically even detect moon-sized objects. Now, this paper analyzes the likelihood of ejections in two types of systems. One with only super-Earth type planets. Join the Helldivers and do your part to defend managed democracy. Actually, super-Earths are planets with 2 to 10 times the mass of Earth, not related to managed democracy at all. The second type of system that the paper analyzes has super-Earths and one called Jupiter. A hot Jupiter would be a Jupiter-sized planet that's close to its host star. I think you can guess what a cold Jupiter is. While a hot Jupiter might orbit their stars at a distance of 0.015 AU to 0.5 AU, cold Jupiters will orbit somewhere between 1 to 10 AU. 1 AU, or astronomical unit, by the way, is the average distance between the Earth and the Sun, which is 150 million kilometers. There's also a couple of parameters that we should define. One is the orbital spacing parameter k, which quantifies the separation between two neighboring planets in units of their mutual Hill radius, which is the region around a planet where its gravity dominates over the gravitational influence of its host star. Another is the Safarov number, which describes the likelihood of a planet ejecting another body from the system rather than colliding with it during a close encounter. Okay, so what did the authors of this paper find out? Firstly, for systems of only super-Earths with fixed orbital spacing k, planets farther from the host star take longer to become unstable, but their instability is more likely to result in ejections rather than collisions. This contrasts with close-in systems where collisions dominate. Notably, the time for the first close encounter is independent of the system's distance from the star. In fact, they found that if the innermost planet has a large enough semi-major axis, which is the average distance between it and the star, the k parameter seems almost irrelevant. Ejection rates are relatively low in both cases, less than 2% for close-in systems and up to 15% for distant systems. Secondly, for the systems with super-Earths and a cold Jupiter, the orbits of super-Earths tend to change over time, becoming more and more elliptical. Once a super-Earth orbit becomes eccentric enough to cross over a cold Jupiter's orbit, it's just a matter of time until collision or ejection occur. According to this paper, 38% of super-Earths end up escaping in this scenario. This also seems to be independent of k. After these initial ejections, however, more than 86% of the remaining two-planet systems achieve long-term stability. The authors conclude the paper by stating that future theoretical work should allow for more planets as well as a protoplanetary disk, and that more discoveries of FFPs alongside measurements of their masses would be vitally important. Next up, I decided to touch on a subject that's made quite a stir recently: the discovery of 3I Atlas, the third known interstellar object. In this paper, a coalition of astronomers from the United States and United Kingdom investigate the possibility of intercepting 3I Atlas with the Juno spacecraft during its closest approach to Jupiter. First things first, a huge disclaimer. This paper was written by Abraham Loeb, Adam Hibbert, and Adam Crowell. Don't let the fact that Loeb works at Harvard confuse you into thinking this somehow makes him reputable, because he's really not. On July 16th, the same group of three submitted a paper that argues that 3I Atlas is in fact a hostile, alien piece of technology. I remember back when Oumuamua was discovered, it was also Loeb who claimed it was alien technology. Oumuamua, if you don't remember, was the first interstellar object that was discovered back in 2017. There was no evidence of this back then, nor is there any now. These claims are complete speculation and perhaps wishful thinking. Nothing about these objects suggests an unnatural origin. In fact, everything points towards that. Now, this is somewhat anecdotal, but I remember back in university, one of our professors gave us the assignment to read a paper by Loeb about panspermia, which is the theory that the building blocks for life came to Earth from outer space via asteroids. It's a very interesting theory, and it could be true, but this paper was filled with so many holes that even I, at the time a second-year astrophysics bachelor student, could see through it with hardly any effort. Maybe one day I'll find that paper and do a video on it. If you want my honest opinion, Abraham Loeb is not a good astronomer. In fact, he's doing the field a disservice by clinging to these conspiracy theories and promoting them every chance he gets. Luckily, the vast majority of researchers are calling this paper nonsense. That's something at least. To conclude my rant about Loeb's conspiracy theories, let's read a short excerpt from the introduction. Quote, "This paper is contingent on a remarkable, but, as we shall show, testable hypothesis, to which the authors do not necessarily ascribe, yet is certainly worthy of an analysis and a report for two reasons. Number 1. The consequences, should the hypothesis turn out to be correct, could potentially be dire for humanity and would possibly require defensive measures to be undertaken, though these might prove futile. Number 2. The hypothesis is an interesting exercise in its own right, and is fun to pursue irrespective of its likely validity. The hypothesis in question is that the recent interstellar visitor to our solar system, 3I Atlas, is a technological artifact, and furthermore has active intelligence, If this is the case, then two possibilities follow. The first, that its intentions are entirely benign, and second, they are malign, or somewhere in between. To address the extreme cases in turn, in the first case, humanity need do nothing save await the arrival of this intelligence with open arms. It is the second eventuality which is of most concern, and according to the so-called dark forest resolution to the Fermi paradox, would be more likely, as it would neatly explain the singular lack of success of the SETI initiative to date. End quote. Now, of course, Loeb starts by saying he and the other authors of this paper do not necessarily ascribe to this theory, which is a very common cop-out for conspiracy theorists. If you're on the lookout for this or a similar phrase, you will hear them constantly in things like ancient aliens. Saying this gives the authors an easy way out when they are inevitably proven wrong. To very quickly explain what the Fermi paradox and dark forest mean, the former is the postulation by Enrico Fermi that there is such an incredible number of stars and planets in just the Milky Way alone that it should be teeming with life. So how come we have never found any? The dark forest resolution suggests that this is the case because the galaxy, like a dark forest, is either kill or be killed. If a civilization makes its presence known, another will immediately exterminate it for any number of reasons. It's an awesome concept for science fiction, just read The Three-Body Problem by Liu Cixin. The second book in that trilogy is literally called The Dark Forest. That's just a theory though. A space theory. I don't see why Loeb brings it up though, since if it were the correct explanation for the Fermi paradox, then why would these aliens keep sending probes into our solar system and thus make their existence known to us? For all they know, we might be a highly advanced species capable of interstellar flight. They wouldn't know before sending the probe, so it would be an extremely risky thing to do. Stupid aliens. As usual, Loeb's logic doesn't logic. By writing papers such as this, Loeb just gives ammunition to conspiracy theorists and the anti-science crowd. They can point to Loeb, a Harvard professor, and say, he agrees with us. When, as I said, there's nothing to suggest that there's anything unnatural about the 3 interstellar objects we have found so far. This got much longer than I intended. Let's go back to the paper that I initially wanted to talk about. The one about intercepting 3I Atlas with Juno. So, Juno is a spacecraft that was launched all the way back in 2011 and has been studying Jupiter since it arrived in its orbit in 2016. It has done flybys of Jupiter's moons like Ganymede, Europa, and Io, snapped pictures of aurorae over Jupiter's north pole, and has generally been an incredibly successful mission. I won't get into the orbital calculations because this video is already longer than I expected, but the paper does conclude with the finding of a path that Juno could take to intercept 3A Atlas by March 14th, 2026, and that would be really cool, if only to prove Loeb that it's a natural object. For your information, the trajectory that 3I Atlas is on will carry it back out of the solar system, and then it'll be gone forever, so we have a very limited time frame in which to study it. Despite everything I said about Loeb earlier, I do support this move. It would end Juno's mission around Jupiter, but it would give us an amazing opportunity to study an interstellar object from up close. I have no doubt that we will find other such objects in the future, but why not jump at this chance while we have it? Especially considering the Juno mission is expected to end in September anyway. Now, one thing that's not clear is whether or not Juno still has enough fuel, and whether the engines even still work, since they were last used in 2016. That's something that the NASA JPL team will have to assess. Alright, I know I said that was the last topic, but let's detox with something nice. What you're seeing here is NGC 3285b, a spiral galaxy located in the Hydra 1 cluster, over 136 million light-years away from us. This picture was taken by the Hubble Space Telescope. NGC 3285b made the news back in 2023 when a supernova went off on the outskirts of the galaxy, and you can actually still see it glowing right here. Astronomers are now revisiting it as part of a study of 100 Type 1a supernovae, which will help refine our ability to measure cosmic distances. You see, space is not empty. There's a lot of gas and dust just floating around out there, which, combined with distance, will make objects appear redder than they are. So, by observing supernovae in different wavelengths such as ultraviolet, optical, and near-infrared, we can get better at judging distances based on discoloration. That's it for this week's astronomy news. Be sure to hit the like and subscribe button so you never miss a space update. And tell me in the comments if you want to see a deep dive into any of these topics. Until then, stay stellar.